After this,
Got
we're gonna have parts
got
for
the glory.
so,
It's
Connor, take the
thrill of
camera.
the
Yeah,
fight,
there's a
rising
second.
up.
Oh,
the tiger. Guys, I love you.
Rising up, straight to the top. Had the guts, got the glory. Went the distance, now I'm not gonna stop. Just a man and his will.
Alright guys, so you think we need ground turkey or ground beef for this fine fiesta? Because either will suffice.
Well, beef. That's what's for dinner. Actually, Purvis, we want the first derivative of the cost function to be a minimum. You know, Con gave up, so we can save money for college.
In that case, I think we want to go with ground turkey.
Well, what else do we need then?
Cream of chicken soup and an onion.
I'll go grab the soup, you guys grab the onion.
I'll find the best onion.
That one's gross. That one's gross.
Ogres have layers. Ogres have layers. Onions have layers. Cakes have layers.
Hey! What's up? Dude, where's Connor?
It would be ideal if the first derivative of the cost function was negative.
I got the soup!
What, you walk home? Okay, so first we need to find a pan to cook the meat in.
Yeah, that's right. But don't we want to optimize the size of the pan with the amount of meat that has to be cooked in it? Like, you know, if we use the right pan with the most surface area, then we could probably cook the meat faster that way.
So we have this volume of meat, and we're going to press that into a cylinder when we put it on the pan. So we want to find a pan that has the same width as the diameter of the cylinder of this volume of meat, correct? So we can optimize pan size.
Yeah, just crunch the numbers in my head real quick and this one will work.
Yeah, and it would actually be ideal to have our average rate of change to all of our instantaneous rate of change be equivalent to one another.
So
On a graph of meat versus time cooked.
So what you're telling me right now is that we want the amount of meat to be cooked to be directly related to the time elapsed. Well, if you were to graph the function of time with respect to meat cooked, I would see a straight line. Like anything with the first derivative being a constant number, preferably high in magnitude and non-negative, is going to be good. So.
Yeah, that way the cooking is more predictable because the amount of meat cooked is constantly changing with the amount of time elapsed.
Exactly. Yeah.
You know, guys, something else to keep in mind is it would also be most preferable to have a critical number of the function to be as close to 0 as possible. Like, we don't want the meat to cook as soon as it hits the pan, immediately, because that's going to throw us off, and we don't want it sitting in the pan for 15 minutes before it finally starts cooking.
Right. Okay.
I see what you're saying.
So you guys go ahead and cook the meat. I'll get started with this rice.
That's right, Dyson. Oh, here he goes. Oh. Carl, spread.
Sorry.
Hey, Grandma. And we want the secant line of the total.
Bring it to a boil first.
No, it's not fun. Ah, there you go.
Gregory, look at this mess.
I'll walk away.
Know when to run.
2.5 hours.
It's tough.
Sitting at
Hannah,
the
bro,
table.
you don't want to date birds anymore. You can't cook rice.
Oh, I
Gotta be down with the hood team. You don't know how to cook rice. Wait, guys, visualize the heat versus time graph. The whole time that the meat and the onions have been being cooked, the heat has been held at a high constant value, correct?
Yes.
However, after we add milk and soup, the heat is going to instantaneously change to a positive integer with significantly less magnitude, correct?
We're just saying if we're looking at the graph, the right hand limit does not equal the left hand limit. You see what I'm saying?
Yeah, that's what I meant.
Okay. So the function's going to be discontinuous, is that right?
Yeah.
Yeah, it's going to be
Okay.
discontinuous.
And for the same reasons, then the mean value theorem is not going to apply to this function? Is that right?
Yeah, correct.
Okay. And that is because the right hand limit does not equal the left hand limit.
Correct.
Okay. So, due to these aspects of the graph, that would mean that there's no way to quantify the value of the secant line slope.
One of the rules in order to have the mean value theorem. If it's continuous a function, and as we've already clarified, the function is discontinuous.
Okay.
Go calculus. So let's say it takes you 5 minutes to eat one plate of poor man's stroganoff.
Okay.
Right? So the graph of poor man's stroganoff consumed versus time elapsed. Take a closed interval, 0 to 5 minutes. Right? So the absolute maximum of this graph is going to be the end point where the x value is 5, correct?
Right.
Right. And the max y value, the f of x value, is going to be equal to the quantity of poor man's stroganoff. The quantity.
You gonna finish that?
Yeah. Go calculus.